All right. Welcome everyone to the March 2025 Build It with Arduino Meetup event. I'm so glad that all of you are here. Do we have anyone here today that this is their very first time for being with us for one of these events? Okay, Ben. Okay, and Frank. Okay, great. Oh, and Matthew. Okay, great. So So let me go ahead and share my screen, and I'm going to show you what the information is for stuff regarding our events, where all that stuff is at. Okay. Okay, so there is both. Well, maybe Meetup will refresh here. So there is both a Discord server that is set up, as well as the YouTube channel. And if my computer cooperates, I'll be able to show you where those links are at. I don't know why this is not refreshing correctly. Anyway, on the Meetup group itself, on the home page, under the more information about the group, if you click on the hyperlink, Meetup will only show like the first two lines of the description. Okay, what we are about section, and literally the first two lines. And so if you click on the link to show more, then it will actually provide the hyperlinks for both the YouTube channel and also for the Discord server. So that's where the information is at, Terry and everyone else, for getting on to the Discord server. It's a free pass for anyone who wants to join the Discord server. All you have to do, it is by invite only. And so that's just a general policy that Discord follows for everything. So that's why you need to have the link to either use your existing Discord account or sign up for a new one to be able to actually join the server. And so within Discord is where literally all it's both a communication for all of you to here's what I refer to. Read more on the link. So it's a communication channel for all of you to use for each other, and also to communicate directly with me as the moderator for the server. And it's also the place where myself and all of us can upload our files, our links, and share information about our projects that we're doing. So that's the deal with Discord. And then, as I said early on, with YouTube is literally where I have all of the recordings for these events. And so that's going to be an ongoing policy to put everything up there. And so those were the two main points, especially for our brand new people here, that I wanted to share about YouTube and with Discord. So does anybody what I want to do is I want to go through a bunch of material today, both education and kind of show and tell / demo style. And this is a 2-hour meeting. And then hopefully we'll have some work time there at the end, as far as like workshop time, where we can talk about any issues that we're encountering, and do our own show and tells with the rest of the group, and ask questions, either of me or for each other, for everyone who's here. So that's going to be the format for today, where we can do kind of some debug time if needed, etc. So does anybody have any general comments or questions? Nothing to do with debug work, that will come at the end for the workshop time. But does anybody have anything in general that they wanted to discuss, or questions? If not, we'll just launch right in.
I have one question. What is OES Studio?
OBS Studio, was that your statement? Okay, OBS. I'm not sure exactly where you're getting that, but I know I'm not using OBS today, but that's a tool that I use frequently for as an event host for other things that I do. It's considered a live streaming and recording studio. It's open source, completely free. You can use it everywhere and anywhere, completely free of charge. And as I say, it's open source. It's a little bit tricky to set up for various workflows and use cases that you want to use it for. But in general, for hosting online events, for those of us that use Zoom, Zoom alone, the tool set that's provided, it's got some things that aren't necessarily all that great for event hosts. And so that's one of the reasons why I personally use OBS for a lot of things, because it can really jazz things up, provide a lot of engagement within for events that you're hosting. So that's where OBS comes from. Let's see. So the URL for that is obsproject.org, I believe, is the main website for the download, and also their point of reference for their documentation, the help file site and all that. Does that answer your question about OBS? Okay. Terry, did you have any other questions about Discord? Did you find what I was referring to and all that? Let's see. So Terry, you are muted.
Yes, that's great.
Okay, great. All right. All right. So I'm assuming then that there are no other questions. So let's go ahead. Let's see. So what the main thing one of the first things that we're going to talk about is kind of some basic education on the different types or flavors of Arduino boards that are available, and some basics about how to choose. So the first, so I got some great info sites here for us to be looking at. So the Arduino boards themselves have been around, it seems like, forever. Relatively so, as far as number of years. They're relatively new since the advent of hobby electronic experimentation and whatnot. They have really taken off. And over the last couple of years, post-pandemic, in 2024 and already in the start of 2025, there have been a lot more Arduino board products that have surfaced. Now, when I talk about the whole focus of this module today is actually talking about the computer boards themselves, Arduino computer boards, not the accessories that go with them. And I don't mean cables. I don't mean shields, which are expansion modules that literally sit on top of an Arduino board. I'm not, that's not the focus of this topic. Instead, we're talking about the core board, which is like it's literally it's an embedded board, a computer board, a CPU of sorts. Okay. But it's a small scale computer. And so Arduino, as we all know, is very prolific. It's everywhere in the hobby and even in the professional world. And most everything about it is completely open source, completely free to use, consume, and ultimately distribute. And as I say, there have been a lot of new advents or invention, new boards that have come into play. And that's mostly to fill the need of what's called the Internet of Things movement. In other words, boards that help either artists or electronic enthusiasts, roboticists, etc., who use Arduino to be able to directly connect through the internet to do all sorts of things, both locally and over the web. So that's what I mean by the Internet of Things. Again, that's something else that has taken off over the recent years, and Arduino helps to fill that need for creators and experimenters and electronic enthusiasts. The other thing that Arduino has been expanding in for these new 2024, 2025 boards has to do with AI and the idea of being able to utilize machine learning and train your neural networks, all of that AI type of stuff for training and doing like image recognition, object recognition, all that kind of stuff. There have been a bunch of brand new, very powerful Arduino boards that have come onto the marketplace that help fill that need. And so we're going to kind of review some of that. So there are some basic boards where we're starting within this group is in the basic category. That's where the Arduino Uno, the Arduino Mega, Rev 3 comes into play. All of those are in the basic. They are what's called 8-bit controller boards. And to go with the Internet of Things and machine learning AI models, as far as the Arduino boards that are supported there, then we're getting into the space of 32-bit. And so 32-bit compared to 8-bit, for those of you who don't know, 32-bit provides faster, they're faster boards. They're much more powerful boards. It's like the idea if you're looking at a Mac or a Intel PC, something like that. If you're comparing, say, like something just like an old x86 machine to modern laptops and computers, very powerful computers nowadays, there's a whole speed and productivity and all that kind of thing difference. And so that's model is also modeled in the embedded world of comparing, say, 8-bit to 32-bit and even 64-bit. I don't believe that Arduino currently supports any 64-bit boards currently, but I may be wrong on that. So that's kind of the differentiator there. So this particular web page talks about 20 different boards. So there's the Arduino Uno, R3, Nano. So all of these, the main differentials that differentiate all these boards, regardless of those different categories that I've been talking about, has to do with the number of I/O or interface pins that the board supports, either analog or digital pins that are available. There's also the idea about if Wi-Fi is supported on the board. There's whether or not it's an 8-bit board versus a 32-bit board, or processor actually is where that distinction comes into play. So that's a lot of, so if you look up online, if you're using the reference material that I'll be providing to all of you today, you can start digging into this a little bit closer. But you need to understand each of the boards have a very distinct set of features and characteristics, and that is what you need to use as a guide for yourself in purchasing, say, beyond an Arduino Uno. In purchasing upcoming boards that you want to do specific types of projects with, that you need to be looking closely at what the feature set is per board, and also the architecture for the CPU that it's using, all that kind of stuff. Say, for instance, here, if we're looking at the Arduino Uno, that's a 16 megahertz processor board, and it's using what's called an Atmel AVR Mega 328P processor. And so you need to be looking at details like that. Usually across the board with any Arduino board, they are connected as far as programmability from your development machine. That, by the way, we're going to be setting up the development environment today also. Is whenever you have your development system, because we are developing code, downloading code, compiling, and then downloading code into an embedded board, is that there has to be a connector cable that connects those two things together. And so they're across all Arduinos, they are all USB connected. And so you'll see this idea about the USB type connector that's required for the connections, usually throughout any type of Arduino board that you're looking at. And then you also want to be aware of the memory, the amount of memory that's available on that particular board. So they always do a great call out across resources for these boards, as far as giving you the amount of RAM, the amount of EEPROM, and flash that's available. We'll be learning more about these things as we go along, but I'm just pointing out some of the things that you need to look at. You need to get to be very, very familiar with the types of boards that are out there, and understand clearly what it is that you want to do for your project. And then that will help you in choosing the appropriate board for your work. Because this isn't really realistic in today's world, but if money was no object and you could just spend money and just get basically anything that you wanted with no financial worries to do your projects, well, then automatically you might think, well, then I'll just go for the highest end board. Say, for instance, a board that supports machine learning, full Wi-Fi compatibilities, all those kind of things. But in a way, that's from an engineering standpoint, that's never a smart choice, because you're trying to think about, you're trying to do like a flexible solution, a one size fits all kind of solution, when maybe all that you want to do is, say, blink an LED. So it's always smart to pick the right processor board, the right hardware, the right set of features for your particular project. So that's something that you'll need to learn over time. And one of the things that I've recommended for a basic toolkit, so to speak, for all of us to have is utilizing the Arduino Uno R3. That's the standard nowadays for an Arduino board. In fact, as far as I know, the very first marketable, at least, Arduino board was an Uno. So that is the basic, that's the lowest level board that you can possibly get. And it has 14 digital inputs, output pins, along with 6 analog pins. So it's a great little board to get started with. Okay, so that's the reason why I recommend Arduino Uno. Another tighter scoping of board is the Nano. That's kind of like a larger size, old-fashioned through pin IC. That's what the Nano looks like. So that's another potential option, and also I think that's true for the Micro. Leonardo is another very popular board that's out there. And then another one that's kind of like the next layer up as far as sophistication for the number of I/O pins that are available. It has a more powerful CPU or processor that's on it. It has more serial ports that are available. Anyway, it's like I say, it's the next level up. Okay. And then remember we were talking about machine learning and 32-bit processors. Okay. So one of those that's in that category that is a more AI and machine learning available type board is the Nano 33 BLE. Okay, so that's what's being highlighted here on the screen, and that has a different CPU on it than an Atmel AVR. It has a Nordic CPU, and it's a 32-bit ARM Cortex processor, and it's running at 64 megahertz. Okay, it has a huge amount of flash and static RAM, all that kind of stuff. So that's definitely a more sophisticated and faster processing board. So we're not going to go ahead and, I'll be providing all these links that we're going through today after the event, and also within the chat before that all of you can grab before you leave the event today. And let's see. So I think that some of these are more like the Arduino robot. First of all, I'm not familiar with this particular board, aka product, but some of these are very much niche specific type of products or boards. So you kind of want to look at that a little bit. Okay, so some overview as far as some basic features that you want to be looking at. You want to look at which CPU or brain power that particular board has. You want to start there. You want to find out all of these boards, unless we're talking about direct USB power from your development machine, your development computer, over to the board. Remember, I mentioned about the USB cable. One of the things, whenever you've got that board, whichever kind of Arduino board that we're talking about, when you have that board connected by USB to your development box, then that board is literally receiving power from your development box or from your development computer. You unhook that board and you have it as what's called a headless device. Okay, it's not connected to your development computer. Then it has to have its own power source. And so in general, the power supply that's required on these boards can vary between 3.3 volts and 5 volts in general. So you want to be aware, you want to make sure that you've got an adequate system for battery power, etc. And you need to know what that specific value is for the power supply needs. I'd already mentioned to you about the I/O pins, which means the interface to interface electronics to the board. That's what I/O pins are used for. You need to understand the number of digital and analog pins that are available. We'll be learning more about the differences in those two as we go. And then also by default for programmability, all these boards have a USB port that is used for let's see, it's used to connect your IDE or your code development system into the board. It's all by USB. But then there's other protocols, other communication protocols, whether we're talking about I2C, serial. There's a whole slew of those types of communication protocols that are available to connect with other things that the board will be controlling or getting information into it from. And so you want to look at that. You want to understand that picture as well. You also want to look at the clock speed of the CPU. We've already shown some examples of 16 megahertz CPUs. We talked about ones that are much higher than that, like on the more powerful Cortex boards, etc. So clock speed is directly related to how fast the board will process information and execute your code, do its thing that it's programmed to do. Okay, so that's all basic important stuff for you to know. The other thing that we want to look at, I'll go ahead and share another page here for you. Again, for looking at different types of boards. Okay. So this is kind of a general pictorial of kind of what different types of things look at for the different boards. Okay, so here's this is kind of a nice reference page for everyone to have access to, where it kind of gives a general call out as far as the memory that's available. So in general, let me just kind of give you just a quick education moment on embedded memory. Typically, these boards have flash. They have basically, or in this case, static RAM. Okay, and they also have so for the minute, my memory about memory types have gone awry. But flash is used to hold Megan. Flash is used to hold the code base. RAM is used for temporary memory, like for storing of variables and all that kind of thing. So those are two main characteristics for memory. And then they talk about I/O. They talk about the clock speed of the processor and the particular processor that is on the board. And they also give a call out on the Arduino board itself. And so here's a nice kind of one reference point for a nice list of different types of Arduino boards and the actual names. And then they kind of give a nice pictorial view about what that board looks like. Here's that glorified large scale through hole IC that I was talking about with the Nano. It's a pictorial on that. So that's kind of some important things there. And then the last point of reference I wanted to show for a reference web page on this topic They give a more detailed view on the different category types for Arduino boards. From the lowest end, if we're talking about an Uno R3, all the way up to the more sophisticated machine learning AI type of boards. So let's take a little look at that whenever this loads. All right. From basic embedded to advanced AI boards. Okay. All right. Okay. All right. Okay, so there's basic boards, there's the Internet of Things type category, and then they talk about AI boards. So basic boards are 8-bit machines, AI boards are 32-bit machines. Again, the idea about more powerful computer systems. Okay, so they give a real nice call out in here of a whole bunch of different types of, even some of these, especially in the AI board category, a lot of these are very, very brand new boards that have been introduced in here early in 2025 and throughout 2024. There's some really new things that are out there in the marketplace. And then they give a call out on the most popular boards. Here's our Mega 2560 Rev 3. That's a very popular next step up from the Uno board that I personally recommend. Here's a pictorial of the Uno R3. All right. And anyway, and so the main things, okay, so let's talk about some things about how I've already talked a little bit about some things that you want to look at whenever you want to do a match of the board to your project. But let's review that information formally. Okay, you want to know the number of analog and digital pins. Again, the number of those pins, the IO port or pin characteristics of that board directly corresponds to what you can interface that board with. Think about your electronic boards, your sensor boards, your electronic parts, whether we're talking about LEDs or specialized sensors that are just the sensors themselves, let alone boards. These IO boards, or these IO ports, directly connect in with all of that. So that's why the IO pin topography or characteristics is a very important thing for you to be aware of. Some boards, like the Uno and the Mega 2560, they are not internet compatible. You can get attachments or shield boards that attach to either of those boards that will provide Wi-Fi to it, but by default, the native configuration of the boards, of those two boards, don't have Wi-Fi. But if you need to have Wi-Fi, that's a very important characteristic for you to be looking at. Okay, think about the Internet of Things boards category and the AI functionality boards. Those for sure have Wi-Fi included. We've been talking about a lot today about 8-bit versus 32-bit processors. Again, the whole idea about speed and how fast, how CPU intensive your application will ultimately be. Okay, that's where that 8 versus 32-bit processors come into play. As we go through our learning journey with Arduino, we'll be spending a lot of time learning about shields or stackable attached boards that can be placed literally on top of your processor board. That's what a shield is, okay? It's an already pre-contrived, already pre-built subsystem that directly interfaces in with your Arduino board. And some shields, some functions that you want to add to your Arduino board, you need to be aware of if that shield, what that shield directly sits on top of. In other words, some shields, they don't work with, say, the Arduino Mega. They say they only work with the Uno, or vice versa. Some shields will only work with the more higher end Arduino boards. So you need to be aware of what you want. You want to look at natively what your Arduino board provides. Okay. In other words, what's literally on board on that board itself. That's what I mean by native. Okay. And then for other things that are other features of your upcoming system that you're building, the additional things that you want to do can be provided with shields. Okay, let me give you a quick example of a shield board. I primarily have Unos and Megas in my toolkit in my workshop here, and I have quite a number array of shields. Okay, for different functions that I want to add to those boards. One of which is an SD card slot shield. So an SD card is a way to capture in the way of a file system that's on that SD card itself, as far as enabling file writes of information. That's a very popular shield that can be bought. So that's just one example. So you want to be looking at the shield options is what it is I'm getting at for the how to choose list. Okay. And then there are, as we've been seeing pictorially on these web pages I've been showing you, these Arduino boards come in all different types of sizes, real small, and they require a plug-in board to actually. It's not a prefabricated board that it comes with, but instead you have to use a different system to actually interface with the board. And those boards, they come in all different types of sizes. So if it's, say, for instance, if this board is going to be going into a real small robot, say like a mini sumo robot, you need to be very conscious of the size of that board, making sure that it's going to fit on your system. So the overall board form factor is very important for you to be aware of. You need to be aware of what the power supply requirements are for the system for that board. If it's 3.3 volts or 5 volts, you need to be aware of the number of serial ports that are on the board. Serial and what's called PWM compatible I/O pins. PWM is used for controlling, say, DC motors or servo motors. We'll be learning more about what PWM is and how to interface and use it as we go along. But again, that's all kind of part of this communication network or options that we all need to be aware of in picking our Arduino board for our particular application. And then other popular communication protocols besides the I/O pins, other methods to connect something to your Arduino board has to do with communication protocols that board supports. Besides serial or what's called UART, okay, there's SPI, there's I2C, and so you need, and then there's likely some others as well. You need to be aware of the number and what it is that's supported on the board, so that you can adequately communicate with your attached sensors, other boards, etc. And then, as I talked about, the idea about different types of memory, there's flash, there's RAM, and there's EEPROM. That was the one that I couldn't remember off the top of my head before. So flash is used in general to hold code. All right. RAM, specifically static RAM, is usually the type of RAM that are on these boards. That's used for volatile memory. In other words, variables that are allocated during the run of a program. That's where variables and stuff like that are stored, is in RAM. And then EEPROM is what's called non-volatile memory. So non-volatile memory is where your resident, always available data is stored for your system. In other words, non-volatile memory has to do with that once the power is turned off of the board, that memory will remain. It doesn't have to be directly powered as RAM memory does. Okay. And then also, as I'd mentioned before about shields, you need to understand what natively designed features are on the board versus for anything that's missing on the natively that you can find and have access to a compatible shield board that will fit the rest of the feature needs. Okay. And across all of these boards that we've been talking about, they are all very inexpensive, even if we're talking about the high scale 32-bit AI machine learning type boards. They are all relatively inexpensive, and they're very easy to get from most any online supplier nowadays. So it's a great, it's very, they're very, very easy to get. And like I say, they're all in the inexpensive modeling. Okay. Okay. And so what we'll do from here, so I'll go ahead and stop share here. And then I'll take your questions and your feedback about this education module of flavors of Arduino and some basics about how to choose. All right. Does anybody have any questions or comments? Or I hope I haven't put people to sleep. I certainly didn't want to do that. Everybody looks like they're awfully relaxed in their chairs. So maybe that's good or bad. What kind of questions do people have on this topic? Again, I'll be providing those links and stuff at the end here today, and also after the meeting in the Discord channel or server. Okay, so that you'll have all that information available to you. Okay, well then I will go ahead and we'll get started then with the next segment. The other thing that I wanted to cover with everyone today is the basics about getting your development environment set up. Hopefully everyone on the call and who wants to participate in learning activities within this meetup group have at least one Arduino Uno that they have in their available to them, or an Arduino Mega, something something that's real easy to start learning on, because that's something in general with electronics and embedded systems you want to kind of start small. You want to have build something that's in the computer industry called a hello world. And that's part of what it is that we're going to do today, provide instruction on, is how to, if you're talking about a regular desktop computer or Mac versus an embedded system, developing code, as a lot of us on the call here, including myself, come from a software development realm. And a lot of us, including myself, we were educated and have direct experience in writing code for a traditional computer or server environment. But when you want to transfer those skills, either professionally or as a hobby, into embedded systems, it's a slightly different model, and different problems crop up in transferring that education over into embedded systems. And so that's part of what it is that I'm so impassioned about this group, is helping to share and educate people about what it takes to get an embedded system up and running with basic code. And that basic code is called like getting a hello world, or a basic proof of concept, because there are so many different details that need to happen in the embedded world that are just kind of automatic, and the developer doesn't even think about them on the regular PC or server environments. So one of those is the idea about having your development system set up. And part of what it is that we're going to be starting with is getting what's called the Arduino IDE. Again, something else that's completely free for Arduinos. The source code, the IDE, and all that is freely distributable and usable. And so we'll be where we start off as Arduino or embedded developers with these boards. It's always smart to start for that proof of concept, for that basic startup, and make sure that you've got everything functioning before you move into higher scale projects. Okay. Is you want to get a basic hello world proof of concept project set up, so that you know that that your tool chain, that your tools are all set up correctly. You've got a basic functioning system at the development environment level in your development PC, and its related tools, and that interface with your development board, in this case Arduino boards. And so you always want to start there. And the easiest way to start for your development PC is using an Arduino IDE. Now, as we go along, we'll be learning pros and cons about that IDE system. And we'll also be learning about other possibilities for other ways of developing code, whether we're talking about different IDEs than the Arduino, like Platform IO. And we'll also be learning about other languages that are supported either directly on the Arduino boards themselves, or that help that are actually used, say like a Python script, all that kind of stuff, that can actually be developed and utilized along with your Arduino board to help supplement your functionality and provide richer projects for your Arduino boards. So we'll be learning not only other development environments besides the Arduino IDE, but we'll also be gradually learning about different programming languages. Now, the default programming language that is supported within the Arduino IDE is a combination, kind of a hybrid combination of the C language and the C++ language. And so whenever you're starting out with these Arduino boards, you're going to want to start learning and leveraging the libraries, the functionalities functions or methods that are provided for you with the Arduino IDE environment, and learning those types of skills in addition to setting up the development environment and getting your board connected, your Arduino board, into your development environment. So the whole way that we're going to start with using the Arduino IDE is to get the development environment set up, start reviewing a bit about how to use the IDE, okay? And then also how to start programming, developing code, compiling it, and then ultimately downloading it, uploading it into your board. Okay, so that's kind of where we're going to start. And as I say, the Arduino IDE is all based, the primary code base, or excuse me, language that you want to learn for the Arduino is C and C++. I'll get into more of that as we go along today. And some basics about what an IDE is, whether we're talking about the Arduino IDE, or we're talking about Platform IO, or some other IDE that's out there. An IDE is a convenient package of tools that ultimately hide a lot of the intricacies of how to work in an embedded environment to get code written, to verify that it is compilable, and to ultimately download upload it or download it into your board. And it's a convenient package of tools. And a lot of the IDEs include debugger tools, either native direct debugging or via a simulator. So that's something else that we'll be looking at over time. The IDE provides a simulated environment to help with debugging as well. So debugging is another whole classification of learning area here, but I just wanted to mention it briefly. So an IDE is a set of tools that are all within a GUI environment. That's the basic of that. And so the way that I want to start this tutorial is I'm going to share with you a video. I have a set of videos that can explain all this very, very well to all of you. Oops. I'll be not minimize. Okay. Shoot. Oh, crap. Remember we were talking about speed of a computer? Well, on this particular computer that I'm hosting this event on, it's a modern laptop, but it's not as powerful as some of the others that are out there. So I apologize for the lag time, but that's what we've got. Let's see. Maybe this is going to launch. I may end up having to ask Lloyd to play.
Yeah, no, I was just going to say, if you shoot me the link, I can bring it up.
Right. Okay. So
hang on, let me get
that's what we'll do. Yeah. I apologize for this, everyone. So okay. Lloyd, I did put the YouTube link in the chat.
Okay, hang on, I'm finding it.
And I'll ask you to start playing that at a specific point for what I wanted to share today.
No one seems to know this, but Amazon actually has a $15 million fund that they have to pay out every
okay. I am ready when you are.
Okay, so go ahead with that YouTube video that popped up, Lloyd. Go ahead and open the details via the more link for the description on that particular video, and click on the details for the various points that you can skip to, and go ahead and select the 7-minute 30-second link that's on there.
Oh, okay. Hang on, I've got the wrong one. Let me get that fixed. Not seeing the 7-minute 30-second version.
Okay, well, so whenever you click on the link, then the video itself is showing right there at the top. So what I'm asking you to do. Oh, okay.
Oops. Oops, hang on. Showed the wrong screen. Okay.
Okay. All right. Okay. So okay, great. All right. So if you scroll down on that page that we're looking at,
Yep.
all right, and you click on that more details right
That's
there.
what I missed.
All right. So that's what you missed. So if you click on that link for 7 minute, 30 seconds in, that's the one I'd like you to start with. And then to play it until 26:20 for the play on it.
Okay. Sounds good.
Okay. All right. So we'll oh yeah, and then of course be sure to share your audio, Lloyd.
Yeah, it should be shared.
Okay.
If not, somebody say something.
You'll need a software tool called the Arduino IDE. There are different versions of the Arduino IDE available on the official website. However, for this course, we will use Arduino IDE 1.8. It is a beginner-friendly software tool and works well with any Arduino board. It provides a simple platform for
Any
beginners
chance we can get AI
code
software to stop
according
trying to
the
sell me
Arduino
stuff
codes.
and get my stuff working so I don't have to buy a new computer at Target?
Make sure to choose the correct version for your computer. Click on the download link that matches your computer's operating
Guys, it could just be me, but I can't really hear it all that well.
and the file size is relatively small, so it shouldn't take too long.
Mhm.
Now, open the downloaded file to start the installation process. The installation process is straightforward and user-friendly. Just follow the on-screen instructions and you'll have Arduino IDE installed in no time. After installation is done, you can launch Arduino IDE from the Start menu or the Applications list. Now the Arduino IDE is installed and running. So navigate to the Files menu. From the drop-down menu, select Preferences. In the Preferences window, first, increase the font size a little bit to make the code more readable. Next, let's enable line numbers to help you keep track of your code. You simply select Display Line Numbers checkbox, and the line numbers will appear on the left side of the Arduino IDE. Now, let's talk about the path setting. This is the location on your computer where your code will be stored. So whenever you save
Hello?
your code, it will be stored in this location.
Yep.
You don't need to worry about the other settings for now. Simply click the OK button.
Whoever's playing the video, I can't hear it very well. Would you please turn it up?
Okay. It's actually full volume on my system, so
It seems like me and a couple other people can't hear the video very well.
okay.
So,
Let me see if there's something I can do with that.
There's a link to the YouTube video in the chat in case folks
Oh.
want to save it for later.
Yeah, I'll be providing at the end of all this. I'll be providing a bunch of the full set of links at the end. Okay, so that all that is coming. Okay.
Yeah, let me reshare and make sure I hit the button to share the audio as well. Hang on.
Is this a commercial?
No. This
No.
is not a commercial. This is education. I'm not sharing any kind of commercialization at all. This is only for instructional purposes to help. It's just it makes it a lot easier for me if I can show you good quality instruction. And so that's the whole thing. Okay.
Oh, so this is not. I mean, we have good relations with Italians, and I like the Texas Instruments too. But the problem I'm having is I don't want to have to get on a bus and download an operating system, get into the registry, go into airplane mode to get this AVR dude out of my system so I can get my OLED working. So I don't.
Okay, Lloyd, go ahead and play.
Yep. And I did put it to stereo, so that might help.
Okay.
Your Arduino board to your computer using a USB cable. Make sure your board is powered on. If you will see the green LED indicator, it means the Arduino is powered on. Now, you are ready to upload your first program onto your Arduino. Before you upload the program, you need to tell the Arduino IDE what kind of Arduino you have. So, go to the Tools menu, and then go to the Boards option. Here, you will find a list of supported Arduino boards. Simply choose the one you have. For example, I will select Arduino Uno. The last step before programming is to tell the IDE on which COM port your board is connected to. So again navigate to Tools, and then go to the Port option. As you can see, the Arduino board is connected on COM port 5. You just select the COM port, and you're good to go. Now we are ready. Let's make sure that everything is working as expected. First, navigate to the Files menu. From there, go to the Examples. Here, you will find a collection of code examples to perform various operations. You can try it yourself. From the basic section, you just open the blink sketch. This is a simple sketch that blinks the onboard LED. The Arduino have an LED connected to the pin 13. And we are going to blink this LED. Before uploading the sketch to the Arduino board, let's ensure there are no errors in the code. You just click on the Verify button, and Arduino IDE will check for any mistakes in the code. If everything is correct, you will see a Done Compiling message in the bottom status bar. If there are any errors in the code, the error message will be displayed here. Now, it's time to upload the code to the Arduino board. You just click on the Upload button, and Arduino IDE will transfer the code to the Arduino board. As you can see, the onboard LED start blinking. It means everything is set up perfectly. Now we have tested our setup and it works fine. So let's dive into programming. First, open a new sketch in the Arduino IDE. Here you can see, a program with some code is already written for you. A program is just a set of instructions, and it performs specific tasks, such as turning on an LED, or driving a motor. In the context of Arduino, a program is also called a sketch. Arduino uses the programming languages C and C++, which are the most widely used languages of all time. These are extremely powerful and versatile languages. However, programming in C or C++ can be a bit challenging for beginners. The good news is that Arduino follows a structured programming approach, which provides you a well-defined way of writing a program.
This may look like your favorite childhood crispy treat, and with delicious flavors.
Let's take a closer look at the basic structure of an Arduino sketch. An Arduino sketch is divided into two main parts, void setup and void loop. These functions are very important and must be included in every Arduino sketch. Without these functions, the sketch will not compile, and it will give you an error message. Let's see what happens when we try to compile the code without the setup function. The Arduino IDE will show an error message in the console. It reminding us the importance of having the setup and the loop functions. It is important to note that every Arduino function has its own name. For example, the name of this function is setup. If you notice, the color of the void setup function is orange. This color indicates that the Arduino software recognizes it as a built-in function. However, if we change the case of the setup function, then you will notice it turn into black color. This means that Arduino doesn't recognize it anymore. The reason for this difference is that the Arduino code is case sensitive. So always use correct case, otherwise the program will give you an error message. This is an important point to remember, especially during late-night coding sessions. The code for each function is written within curly brackets. It is called the body of the function. The opening curly bracket indicates the beginning of a function, while closing curly bracket indicates the end of a function. It's required to have matching sets of curly brackets for each function. If you miss one of the brackets, then the code won't compile, and you are presented with an error message that looks like the one shown in the console. The setup function is an important part of an Arduino program, and it runs only once during startup. This means any code written inside this function will execute just once. So this function is perfect for setting up initial configurations or performing tasks that need to happen only once. The next function is the loop function. This is also highlighted in orange, so the Arduino software recognizes it as a built-in function. Instead of setup function which runs only once, the loop function runs over and over again. The code written inside this function runs continuously until you press the reset button on the Arduino board, or you just remove the power. Inside setup and loop functions, you will notice some text written in gray. These are comments. Comments are written in plain English and provide explanations about the code. The Arduino software completely ignores comments during compilation and uploading, so they won't affect how the code runs. This comment is started with the double slashes symbol. It means it is a single-line comment. Single-line comments are perfect for adding short explanations to a specific lines of code. There is also another type of comment called multi-line comment. Multi-line comment starts with a slash, followed by an asterisk symbol, and ends with an asterisk symbol, followed by a slash. Multi-line comments are used when you need to add more details for the code that expand to multiple lines. Comments are helpful to improve the readability of the code. When someone else reviews the code, clear comments can help them to understand the logic and purpose of each section of the code. Alright, now we have covered the basic structure of an Arduino program. Now, we are ready to dive into writing our very first Arduino code. As you know, Arduino comes with a built-in LED, which is connected to pin 13. Our goal is to create a simple sketch that makes this LED blink. The first function you will need is the pin mode function. This function allows you to configure a specific pin on the Arduino board for either input or output. I have used pin mode function inside the setup function because it needs to run only once when your program starts. You'll notice the word pin mode is highlighted in orange. As I mentioned earlier, it tells you that Arduino already knows about this function. If you look at the case of the pin mode, the letter M is written in uppercase, and there are no spaces in the function name. This is known as camel case style, where the first word is in lowercase, and the first letter of each next word is capital. For example, digital read, analog write, and so on. So the pin mode is written in camel case to follow the standard naming conventions in Arduino. It's not only increase readability of the code, but also ensures that Arduino recognizes and interprets these functions correctly. This function needs two parameters. The first one is the pin number. This is the pin number on your Arduino board that you want to configure. For example, the onboard LED is connected to the pin 13, so if you want to control the LED, you'll set the pin number as 13. The second parameter of the pin mode function is called mode. This parameter indicates how you want to configure the pin. There are two options you can choose from, input and output. If you set the pin as an input, it means the pin can receive signals from external components like sensors. This is perfect for gathering data from the outside world. On the other hand, if you set the pin as an output, it allows you to control external components like LEDs or motors.
This is what happens to your body when you eat cheese.
Watch this before eating cheese.
Number 1.
In our case, since we want to control the LED, so we will set it to output. Notice that the word output is written in uppercase, and the color is blue. Whenever you see uppercase words in blue, it means they are predefined constants in the Arduino language. We will explore more about constants in the upcoming sections. That's all you need for setup. Next, moves on to the loop function. The first function you will need here is the digital write function. With this function, you can send a digital signal to a specific pin. The orange color tells that the Arduino already knows about this function, so we are in good hands. This function needs two parameters. The first one is the pin number. This is the pin number on your Arduino board that you want to control. In our case, the pin number will be 13. Now, let's talk about the second parameter, which is called signal value. It can be either high or low. As we have discussed earlier, the digital signals have two states, either off or on. In electrical terms, these can be referred to as either a high or low value. Since the Arduino Uno requires 5 volts to run, so the high value is equal to 5 volts, and low value is equal to 0 volts. So, we will set the signal value to high. It will send 5 volts to the pin 13, which is enough voltage to turn on the LED. So, with just a single line of code, we can light up the LED connected to pin 13. Next, we will add a delay of 1 second. The delay function stops the program for a specified amount of time in milliseconds. In our case, the value is 1000 milliseconds, which is equal to 1 second. During this time, nothing happens, and the LED remains on. After the delay, we use the digital write function again. But this time, we will set the signal value to low. This statement tells Arduino to send 0 volts to pin 13, which will turns the LED off. Finally, we will add another delay to keep the LED off for 1 second. Since this code is placed inside the loop function, so it will run over and over again, and it will give you the blinking effect. Before you upload the code, let's cover one more important concept. You'll notice that each line of code ends with a semicolon. The semicolon plays an important role in the C language. The semicolon tells the compiler about the end of the statement. It's like a full stop in a sentence, which tells the compiler where the one statement ends and the next one begins. If you forget to include the semicolon, the compiler might get confused and show errors when you try to compile your code. So, to keep your code running smoothly, always remember to include a semicolon at the end of each statement. Now, let's upload this sketch to the Arduino board and see the magic of the blinking LED in action. As you can see, the LED is now blinking just as we expected. It shows the code is working fine, and our LED is dancing like a disco star. How cool it is! But remember, this is only the beginning of your Arduino journey. Let's take a closer look at the code and understand how the microcontroller runs it. When you power on the Arduino, the program starts running. It begins by entering the setup function. It executes the instructions one by one, ignoring any comments. In our case, there is just one instruction, which sets pin number 13 to output. This tells the microcontroller that we want to interact with external components, like LEDs. After executing the instruction, there is a closing curly bracket. It indicates that the setup function ends here. As the setup function runs only once, so the microcontroller moves on to the loop function. Inside the loop function, the microcontroller repeatedly executes the instructions to create the blinking effect for the LED. The first instruction tells the microcontroller to send 5 volts to pin number 13, which lights up the LED. The next instruction tells the microcontroller to wait for 1 second. The microcontroller follows this instruction and waits for a second. Then, it moves to the next instruction, which tells to send 0 volts to pin number 13, which will turn off the LED. And once more, it waits for 1 second. After this, we have a closing curly bracket. It indicates the end of the loop function. Now, the microcontroller goes back to the start of the loop and repeats the instructions from the beginning. There you have it. The beauty of the code lies in its simplicity that keeps everything running smoothly. I have used Tinkercad to create the code simulation. Tinkercad is a powerful online tool that offers a user-friendly environment to design circuits, and it provides a simple tool to write code for Arduino boards. Tinkercad has everything you need, including sensors and a breadboard, making it perfect for beginners to experiment and learn. Tinkercad also provides a built-in code editor. It is fully compatible with the Arduino IDE. You can simply paste your code here and run it by clicking on the Start Simulation button. Tinkercad comes with a powerful built-in debugger that will take your learning experience to the next level. You can debug your code by adding breakpoints on specific sections of your code. Breakpoints allows you to stop the program's execution and examine what's happening. Let me show you how they work. To set a breakpoint, simply click on the left side of the line where you want to pause the code. This blue indicator tells that the breakpoint is active for this line. Now, let's see it in action. So, click on the Step Over button to execute the code line by line. This incredible feature makes it easy to understand how your code behaves at each step, which is extremely valuable for learning and troubleshooting. So we will use it a lot throughout the course. Now, let's move on to the next section.
Okay, Donna, there you go.
Thank you, Lloyd. And so this is just one little small section of this video. Again, I'll be sharing the link for everyone after a bit here. I did want to make a quick note about that Tinkercad that was mentioned. Again, I'll be putting the link for that for signing up and getting an account for Tinkercad at the end of this session today. But basically, Tinkercad is, as was talked about just now in the video, is a great way to enable debugging within the Arduino IDE. Okay, so that's one purpose of Tinkercad. The other is that you can use it in isolation, all by itself within your web browser, to hook up external components to your Arduino, and you can also just kind of do some basic experiments. The idea of running it in solo fashion like that is that you can experiment with Arduinos without having actually any physical components or boards. You can literally run everything in a simulation. So if I recall with the Tinkercad program, is that it's more geared towards just basic electronics parts and that kind of thing for the part selection. It's not real specific as far as specific types of shields or things like that. There's other types of programs that are available for that type of learning and simulations. But Tinkercad is a great place for you to start, for us to start, for learning in a simulated environment. It's great for if you don't have hardware and you still want to get in and experiment with Arduino and embedded programming. Okay, so the other another video that I would like for Lloyd to play, please. I'm going to go ahead and put that for Lloyd in the chat. Okay, and so this will just be a real quick, just few minute video play on this one. This is going to be talking about the serial monitor or serial communication interface that's available in the Arduino IDE, which is a very powerful feature that's available for debugging and getting direct communication to and from an Arduino. So that's what the serial monitor is for.
Okay, let me get that up here. Hey, Donna, quick question while I'm getting this keyed to the right spot. I'm not sure I've got. Hang on. FAQTW. Yeah. Do you want people to install the legacy 1.x version or
yeah. Oh, I'm sorry. I didn't touch on that. And so, okay. So for the Arduino IDE itself, let's see. Let's see. So that's available off of the website arduino.cc, and you click on the software tab is where the IDE is at. So there's at least two versions of the Arduino IDE. There's one that's considered cloud-based, and the other is an actual physical install on your development system. I personally prefer the latter, but a lot of people develop code completely in the cloud. I don't personally like that for a number of reasons. So the installer that was talked about in that YouTube video and that I personally recommend is the actual installer. I don't remember the exact version number that the IDE is at right for the minute, but if you go over to arduino.cc and click on the software tab, is where you will see a call out on that information. So yes, the actual install IDE is what I'm referring to, Lloyd.
Okay. Yep, the current version is 2.3.4.
Okay, all right, right. Okay, that makes sense. Okay.
Nice and convenient. Okay, ready?
Yep, you bet.
We got an ad here starting, so.
It takes just 2 seconds to weld a spot. Let's move on the next section.
Lloyd, you're not sharing your screen.
Not an exciting
tool. Thanks. Okay, let me just tweak this back a couple seconds.
Let's move on the next section. In this section, we will explore an exciting tool in the Arduino IDE called Serial Monitor. It is a powerful tool that allows communication between your Arduino and your computer. It enables you to monitor the sensor values in real time directly on your computer screen. The best part is, it works in both ways, so you can exchange data between your computer and Arduino. This tool is particularly useful for finding and fixing issues in your code. Let's write some code to kickstart the serial communication with your computer. First, in your Arduino sketch, you will need to add the serial.begin function. This function is responsible for starting the serial communication. Now, you might wonder about the number inside the parentheses. This number is the speed at which your Arduino communicates with the computer. It is also called baud rate. The standard speed is typically set to 9600. In simple terms, this line of code tells the Arduino to start communication with the computer at a speed of 9600. After establishing the serial communication, you can use the serial.println function to send data from your Arduino to the serial monitor. Let's give it a try. In this example, we'll send a simple hello world message to the serial monitor. Inside the println function, I've written the text hello world within double quotation marks. In programming, when you want to print text, you always need to write it within the double quotation marks. Now, let's test the code by uploading it to the Arduino. The code is uploaded, and to check the output, you need to open the serial monitor. You can open it from the Tools menu by clicking on the Serial Monitor option. You can also open the serial monitor from the top right corner by clicking on this button. Here is a keyboard shortcut for the lazy ones like me. Press Ctrl plus Shift plus M from the keyboard and it will open the serial monitor quickly. Here, first you need to select the baud rate, which is 9600. Since we have set the baud rate to 9600 in our code, it's required to match it in the serial monitor as well. If you select a different baud rate, you may see unexpected or garbage data in the serial monitor. Now, take a look at the output in the serial monitor. It's just as we expected. The Hello World message is beautifully displayed on the screen. That's a quick introduction of the serial monitor. and we will use it a lot in the upcoming sections of this course. Now, let's move on to the next section of the video.
Okay.
Great, great, Lloyd. Okay, so there is one last video that I'd like to have Lloyd share, and to close out today's instruction, to do with some basics as far as interfacing electronics to an Arduino. Very important starter information for all of us to consume. So Lloyd, go ahead and start that out when you have a chance, please.
Okay.
For share.
And you want to from 106 to 2742?
Yep.
Okay.
Hey everyone, welcome to the world's first.
And you're not sharing your screen yet, Lloyd.
Oh, thanks. Let me do that.
You wouldn't settle for bait man
That's
when
an
there's
ad.
Batman.
Let's start by understanding the core principles of Arduino using an example. Let's say we have a smart car that is equipped with automated headlights. This car checks the light intensity of the environment and turns on at night and turns off during the day. So what sort of equipment would be required to build such a system? We would need a headlight to output the lights and a light sensor to give us information of the ambient light. Now there has to be something in between that gets the input from the light sensor and outputs the signal to the headlight. This something is the brain of the system. We call it the microcontroller unit. In short, MCU. MCU is like a small computer that can handle small amounts of information really fast. So where does the Arduino come in? Arduino is a company that produces microcontroller boards. They have different versions that cater different scenarios. The most commonly used is the Arduino Uno. They also have more compact versions like Arduino Mini and bigger versions that can handle more sensors like the Arduino Mega. The main difference is the size, capacity, and number of pins between these boards. Uno has 14 digital and 6 analog pins. Mega has 54 digital and 16 analog pins. This means we can connect 20 different sensors and devices to Arduino Uno and 70 to the Arduino Mega. Note that the Arduino does not produce microcontrollers. They produce microcontroller boards that contain microcontrollers. So what's so special about these Arduino boards? Even though when referred to Arduino, the hardware comes to mind, but the speciality of the Arduino is in its software. It makes the process of programming much easier than any other similar device out there. In earlier times, we used to write tons of lines of code just to turn on an LED. But now with Arduino, we can achieve the same result in just 3 simple lines of code. So we can say it is a high-level language that takes care of the coding details for us so that we can focus more on the actual project. So how does the Arduino work? As mentioned, Arduino has its own software through which we can program different sensors and devices, and we can upload it to the Arduino board. We can use a regular USB connection to upload the code using a computer. Once the code is uploaded, it keeps running as long as it keeps getting the power. So let's have a closer look at the most commonly used Arduino, the Arduino Uno. The main component is the MCU that handles all the logic. Then we have the USB connection to upload the program to the board. We also have a power jack that allows external battery to be connected to make it portable. The reset button resets the code without deleting it. Then we have the pins where we attach our components. We have 13 digital pins, 6 analog pins, and we also have power pins with 5 volts and ground. So what do these digital and analog pin mean? Digital signal has only 2 states, which means it can be on or off, whereas analog signal has a range of states. Let's look at an example of a fan. If we control the fan digitally, we have the option of turning it on and turning it off, where on would mean 1 and off would mean 0. If we control the fan with analog signal, this would mean we have a range of values. Therefore, we can now control the speed of the fan rather than just on and off. For example, the range is from 0 to 255. 0 would mean off, 255 would mean full speed, whereas 127 would mean half the speed. But where did this 255 value come from? Well, this is an 8-bit value, which means we have 256 values. Bit values are used all around us. For example, when you buy a smartphone, you have the option of buying a 64 GB, 128, 256, 512, or even 1 terabyte hard disk phone. So where do all these random values come from? These values are binary values, where 64 is basically 2 to the power of 6, 128 is 2 to the power of 7, 256 is 2 to the power of 8, 512 is 2 to the power of 9, and 1024 is 2 to the power of 10. This means if we were to send a 6-bit signal to our fan, we would have 64 different speeds to control. If it was an 8-bit value, we will have 256 speeds to control. If we include the 0 as well, then our values will range from 0 to 255. Coming back to our automated headlight example,
did you know that Amazon has a $50 million fund that they have to pay out every month? And here's how
we have an analog input in the form of the light sensor and analog output in the form of a light. Now this time we will use the Arduino controller to run the system. For analog input, Arduino uses a 10-bit value, and for analog output, it uses an 8-bit value. So this means for our light sensor, we get a range of values from 0 to 1023. So 0 would mean dark, and 1023 would mean fully bright. Similarly, based on the light intensity we received from the light sensor, we can output a value to the headlight to turn it on accordingly. For the 8-bit value, we have the range of 0 to 255. So we will have 256 brightness values. Let's have a look at some examples of input and output devices. A distance sensor would be an analog input, a push button would be a digital input, motor would be analog output, whereas LED light would be a digital output. The distance sensor is an analog input because it gives us a value of distance, for example in centimeters, rather than just saying the object is near or far. The push button is a digital input because it has only 2 states. It can either be pressed or not pressed. The motor is an analog output since it can be controlled with the varying speed. The LED light is a digital output because it can be controlled to be either on or off. Note that the motor and LED can be used both as digital outputs as well, since they both can be simply turned on or off. So, to summarize, Arduino is a company that produces microcontrollers, which we can use to control multiple sensors and devices. These devices could be inputs or outputs of the system, and we can have 2 different types of signals that we can send or receive from these devices. Now, these signals can be digital or analog. Digital signals have two states, whereas analog signal has a range of states. For analog input, the Arduino uses a 10-bit value, which ranges from 0 to 1023, and for analog output, it uses an 8-bit value, which ranges from 0 to 255. In this video, we have just scratched the surface of the Arduino microcontroller, as there is tons of information related to Arduino. To truly understand it, we have to get our hands dirty by experimenting and inventing new projects. The possibilities are endless. We can even build our own custom Arduino boards and use them to create our own projects. In the next video, we will look into the details of how different sensors could be connected to Arduino and how we can use the Arduino IDE to code them. We will see step by step how the connections are made and how we can read and write information from different sensors and display it to our screen. So how can we connect sensors and devices to Arduino? In this video, we will look at the basics of sensor connections and their coding. So we have a lot of sensors and devices that can connect to Arduino, and there is something that is common in most of these devices. So what is that? It's the power pins. Most of them have a positive and negative pin. Let's take an example. This is a temperature sensor that has 3 pins. The first pin is the negative or the ground. It is also referred as G and D sometimes. Then we have the positive pin. Most of the times it is denoted by the voltage level, for example 5 volts, 12 volts, and so on. The last pin is the signal pin, mostly written as S. Now, depending on the sensor or device, it can be input or output. In this example, we are getting values from the temperature sensor, therefore it is an input to the microcontroller. In other examples, such as a buzzer, the signal would be an output. So how do we connect these pins to Arduino? They can be connected by special wires known as jumper wires. These are easy to use and plug in directly to most sensors and microcontrollers. Jumper wires have 2 different types of heads. The one with the pin is known as male, and the one without is known as female. So when purchasing jumper cables, we have the option of purchasing 3 different types. The one we see here is male to female, since one end is with pin and one is without. Then we have male to male and also female to female wires. So which sensor is connected to which pin number of the Arduino board? As we discussed earlier, the signals can be of analog or digital type. In Arduino Uno, we have 14 digital pins and 6 analog. So one could say that all analog devices are connected to the analog pins and all digital devices are connected to the digital pins. Well, that is not correct. Since Arduino does not have true analog output, most of the analog output devices, such as motor and dimming lights, are connected to digital pins where we send a simulated analog signal. We will discuss this more in detail in the upcoming videos. For now, we can say that the analog pins are mostly used for analog input, and for the rest, we use digital pins. So let's see how we can connect an LED light to Arduino. As we know, an LED light has a positive and a negative connection. So we will connect the negative pin to the ground and the positive pin to one of the digital pins, let's say pin number 2. But with LED light, we should use a resistor to limit the current to avoid burning the LED. So we will need to use a breadboard. When using Arduino, many projects require the use of breadboard. So it is a good idea to learn the basics using a breadboard. So a breadboard consists of power pins and component pins. Here we can see the conductive layers inside a breadboard. The connections in the power pins are vertical, whereas the connection in the component pins are horizontal. This means that this point at the top of the breadboard is connected to the bottom of the breadboard, whereas in the component pins, this pin at the top is not connected to this pin at the bottom. Instead, this point is connected to the horizontal point here in the same line. The space in the center indicates the breaking point. This means that this point here is not connected to this pin here. So how do we connect the components? Let's look at some examples. Most components can be connected in two different ways. If we connect vertically, they can be connected in the same region. When connecting horizontally, they have to be connected between the gap. This means a resistor cannot be connected like this. The power pins are connected in the power pin section. This way, multiple devices can be powered from the same line. So let's see how we can connect an LED circuit to a breadboard. If we look at the circuit diagram, we can simply follow the current flow. So first we will add the LED, then the resistor, and then the battery. We can label each terminal of the components to further understand this. We will connect our power wires. Starting from the positive side of the battery, the current flows towards the first terminal of the resistor. So we can connect this with the wire here. Then the current passes through the second terminal of the resistor and moves toward the positive terminal of the LED. We can add another wire from the second terminal to the positive side of the LED. Then the negative side of the LED goes to the negative side of the battery. So we can add a wire from the negative point to the negative point. So we can see the current flow and how it creates a loop. So now that we know how to connect an LED light, how can we control it with Arduino? We can simply replace the battery with Arduino, where the negative side will go to the ground and the positive side will go to one of the digital pins of Arduino, which we selected earlier as pin number 2. So when we send a high signal to pin number 2, the voltage level at this pin goes to 5 volts, therefore turning on the LED light. And when we send a negative signal to the pin, the voltage level drops to 0 and the LED light turns off. So let's connect this using the breadboard. First we will add our components. Then we will start from the positive side, which is our pin number 2. We will connect it to the resistor, and then from the resistor we will connect to the LED positive side. Then we will complete the loop by connecting the LED negative to the ground of Arduino. So let's program this LED to blink. In Arduino, we have 3 sections of the code. First one is the initializations and declarations. Second is the setup. And third is the loop. The first one we will discuss later. The setup is the section where we define which pin numbers are our sensors and devices connected to, and whether they are input or output. This section of the code runs only once. Now, the loop is where we run the main code. It iterates over and over again. So in the case of our LED, we would write the code of turning on and off in this section. So let's write the code. First, we will add the setup function. Then we will define that our LED is connected to pin number 2, and it is an output device. For that, we can write pin mode 2 and then output. Next, we will close the setup function and write the loop function. Inside this, we will send a high signal, which is 5 volts, to the LED pin number 2. We can write digital write pin 2 as high. Now we will add a delay of 1 second by writing 1000 milliseconds. To make it blink, we have to turn it off as well. So we will write digital write pin 2 as low and add 1 second delay again. Now we will close the bracket. So this code is enough to run the LED blinking example, but it is not the best way to write the code. Let's say we want to change the pin number from 2 to 5. We will have to replace the pin 2 to 5 manually in a lot of places. This is a simple and short code, so it would not take that long. But imagine if we have hundreds of lines of code, that would take a while to find and replace. So what we can do is to add a variable. Now the variable can be added in the first section of the code that we did not discuss before. So a variable is just like a box that has a name and it can store a value inside. So we will write integer my LED pin is equals to 2. Here the my LED pin is the variable name and 2 is the value that is stored inside this variable. But what is this int? Well, this is a data type. Integers can have values between minus 32,000.
Michael's lowest prices of the season sale is going on now. Get up to 60% off thousands of items. Shop 70
and 32,000. They cannot have decimal values. Now to upload this code to our Arduino board, we have to first define the type of Arduino board we are using. We are using Arduino Uno, so we will go to Tools, Board, and select Arduino. Then we will select the port number, again from Tools, Port, and then the port number. Note that you might have different port number. All you have to do is to make sure that you select the correct port number. Once you have selected, you will see a tick mark next to it. The last step is to click on Upload. And now your Arduino blinking code is uploaded. If you do not have an LED light, you can use the built-in LED light of Arduino to test. The LED light is connected to pin number 13. So all you have to do is change my LED pin to 13. Let's say we have a motor and a 9-volt battery. If we connect them together, the motor starts to move. Now, what happens if I change this 9-volt supply to 5 volts? Well, the speed will decrease. We can say at 9 volts we have high speed and at 5 volts we have low speed. In other words, speed is directly proportional to the voltage. But the question is, what if we wanted to change the speed of the motor without changing the power supply? Because we cannot change the power supply every time we want to change the speed. Well, we could add a resistor. So there will be some voltage used by the resistor and the rest will be dropped at the motor. So the motor will move slower now. So let's say 20% of the energy is used by the resistor and 80% is used by the motor. So the question is, where does this 20% of the energy go? Well, the bad news is that it dissipates as heat. Therefore, this is not a good way of controlling the speed since we are wasting energy. This was the practice up till 1960s, but then somebody came up with a better solution. So let's have a look at that. So let's say we have the same circuit as before, but now instead of the resistor, we add a switch. This switch we can turn on and off. Given that our voltage is 9 volts, if we turn on the switch, the motor receives 9 volts. And if we turn off, the motor receives 0 volts. Now, if we rapidly turn the switch on and off, our average voltage will decrease. So if we turn on for 50% of the time and turn off for 50% of the time, then our average voltage will decrease to 4.5 volts. Now, if we turn on for 80% of the time and turn off for 20% of the time, then our average will be higher, which will account for 7.2 volts. Similarly, if we turn on for 30% of the time and turn off for 70% of the time, the voltage will average at 2.7 volts. So this here is our pulse, and by changing its width, we are controlling the speed. Therefore, the term arises pulse width modulation. The percentage of the on time is known as the duty cycle. So in this example, the duty cycle would be 80%. Now, to implement this on a motor using an Arduino or Raspberry Pi is actually fairly simple. With Arduino, there is a native function, analog write, which takes in the pin number of the motor and the speed required ranging from 0 to 255. Here our pin number is 9 and the speed is 127, which is half of 255. Along with this, we can specify the digital write to change the direction of the motor as well. In Raspberry Pi, the GPIO0 package contains the motor module that allows easy use of the PWM. After specifying your motor pins, you can simply type forward or backward with the value ranging from 0 to 1. To control another device such as LED, the Arduino code would be same using analog write. But for the Raspberry Pi, the PWM LED module could be used, where the value of the PWM can be specified by writing LED.value, and this value is basically the percentage. For example, in our case, it is 0.5, which means 50%.
Okay.
Great. Thank you. Thank you so much, Lloyd, for helping out on that. So, and so
Can I make an apology? Can I make an apology? I'm sorry. Can I? Is that cool? I'm sorry to interrupt you too, but I just feel like I need to do it.
Okay. So let's go ahead and continue on with the meeting. Sorry, we're running a bit late. What I wanted to do, and I'll be providing this information in the chat, is what we've done today is a quick review of the whole IDE section, okay, including those YouTube videos. What we did was we set up the IDE virtually in YouTube, set up the IDE, and then the interface as far as that hello world code or proof of concept was facilitated using the onboard electronics that's on default with the Arduino, specifically the LED, which is assigned to pin 13 for an IO pin. And so that's one way of getting started, doing your proof of concept of making sure that your IDE installation directly interfaces with your board, with your Arduino Uno. And then the next level step that I'll be providing with a handout for a PDF document is actually taking that education a step further and utilizing a breadboard to connect some resistors and some LEDs just to make things simple. And connecting that breadboard connections to the I/O pins on the Uno, and then writing some specific code to do various things. The PDF will be describing that information as far as the concepts and the code that goes with it. And so that takes the programming to a step further as far as where we're actually interfacing some basic electronics in with the Uno. The other thing that I wanted to mention is the idea about next steps, information on utilizing the functions. In some of those YouTube videos, there was specific descriptions as far as functions and or C++ methods that were mentioned that are Arduino language specific. The Arduino IDE consists of a specific Arduino language that it directly supports, okay? And those functions or methods that were mentioned in the videos are specific to the Arduino language. And so I'll be providing the URL for the Arduino language reference material. You'll want to start getting familiar with those functions and methods that utilize C and C++. So one of the things that I recommend that all of you do that are not familiar with C and C++ is I'll be providing some specific suggested textbook content that I recommend that you get a hold of, either electronically or physical books. And also some specifics as far as Arduino technical reference material books. There's a couple of great ones out there that are really fantastic that condense a whole lot of information across a whole number of Arduino boards that I personally recommend, in addition to starting to dig into the Arduino language reference. And so the other thing that I wanted, so one other thing I wanted to mention about the why on the C and C++. So what I'm going to be providing are specific references, not only Arduino familiarity wise, but specifics on the C and C++ languages. Now, the reason why that's important that you have a good solid knowledge of C and C++ is that everything that comes into Arduino programming, you can either use C or C++ syntax, structure, and the whole way that the program is written depends on what the C and C++ language provides to us. But the functions or the libraries, either functions or methods, are provided by the Arduino language itself, which is a separate document. So next month, we'll be getting more into the what and how and whys of all that process, all that knowledge and information. So that's the next way that I want to take this next meeting forward, is to dig more into that. But I just wanted to give you a preface for the languages and the Arduino references that are coming. The other thing, last thing that I wanted to share is, especially for those of us in the room that are a little bit more experienced with embedded programming, embedded boards, etc., or even just on the desktop, is I want to invite everyone for the SRS Robothon groups that I belong to in May, late May. There's going to be a contest day. And we will be offering a series of both beginner robotic contests as well as some advanced ones. And so I want to encourage all of you, again, I'll be providing the links. Those of you who are interested in applying what we're learning here into robotics for interfacing and programming and electronics, that you may want to start thinking about actually entering and building a robot for May 31st. So again, I'll be providing those links in the chat. Let me go ahead and do that next for everyone. And I was hoping that we could have some build time today, but that didn't happen. Again, I apologize. And I'll be providing some links here for us. And that document that I mentioned. Okay. Okay, so this the PDF that I just put in the chat is the one about doing some basic electronics hookup and getting started with programming and doing the compiling and then download utilizing breadboards, external components is in the PDF document. And then I'll also be providing to you the all the full set of URLs. And also I'll be providing secondarily over at the Discord server, I'll be providing this information as well. Okay.
Donna, this is the second time I've heard about not using the libraries. Is it, are you saying as well to go down to the hardware level and learn the code base and keep the libraries out of it? Not necessarily to make your project go longer, but to just learn and
yeah,
keep the
so
abstraction layers.
yeah, so okay, so that's one thing too that we'll be talking about as we go here.
Please.
As we go, is that the Arduino IDE hides a lot of material, a lot of the backbone stuff. And that really comes forward not only with the tool set that the IDE provides, but also the Arduino language itself. There's a lot that's encapsulated and simplified. Okay, so to your point about getting lower level, yes, you'll want to, if you choose to go that way for your learning, is that you'll want to not only move away from the Arduino IDE itself, move to a more sophisticated environment like Platform IO, and then also do be learning about how to directly work with the AVR architecture and all of the programming functionality, where you're getting away from the Arduino language itself and you're substituting writing either your own libraries or utilizing your own code, either in C or assembly language, to actually substitute writing your own stuff, your own code, and replacing it with what was for the provided with the language, the Arduino reference language itself. So that's another whole abstraction and sophistication level. But yes, I do encourage that for learning, but that's not, at least initially for this group, where we're going. We're starting more at the hardcore easy level of higher level abstraction and sophistication that's required by the programmer and developer in utilizing the IDE itself. Okay.
Wow, that was very informative, especially when you went into the AVR. I just I think it would take me a lot longer to finish my project, but at the same time, if I finished it with a bunch of frameworks, I would look at it and go, "Oh, okay, great." But really, if I knew the C language, never mind. I'm sorry.
So to do with C, there's so many great textbooks, like, if you're thinking about university level textbooks on C and C++. You want to get one that talks about the syntax, the structure of these languages. and so, and there's a whole different methodology as far as programming in C versus C++. I'm not going to get into that today, but you want to start learning even for this rudimentary level of sophistication that we're concentrating on now. You want to have a backbone of C and C++ so that you can understand syntactically, if nothing else, the functions that are provided by the Arduino language itself. Okay. And
Thank you.
again, and then again, off of arduino.cc webpage, they give, and that's link is included in the chat materials, is where the Arduino language documentation is at. It gives the functions and the methods. Methods is a term used in C++ and other object-oriented programming languages that specifically talks about like functions that is what C calls a function call or a call to perform something on behalf of the code. So that's what I meant by function versus method. But you'll learn that kind of thing whenever you start getting into C and C++ language information. Because as I say, the languages themselves is what dictates what you can do, the way that you structure your code, utilizing the Arduino language. The Arduino language is really only part of the puzzle here in Arduino embedded programming.
What is the Arduino language written in? Is it written in its own?
It's written in either, depending on what type of functionality that you're looking at. It's written either in C or C++. That the Arduino boards themselves, the architecture, supports. Okay, again, that's a whole level of abstraction up from actually writing at the hardware level.
Is C++ the next? Did that come after C? Because I came from Swift and I'm going away from that.
Yeah. So yes. So C++ in the whole lineage of computer languages came after C. C was more or less like back in the 50s and 60s. That's where the inception and the popularity of the C language got started. Okay.
Oh wow.
So I mean it goes way back. And so then later on, like probably like 10 years later, is when the C++ language came out. That's when object-oriented really started to develop and take off. And nowadays, most every language is either a scripting language or object-oriented or procedural. The C language is a procedural language. Python, for instance, is a scripting language. So I'm not going to go into what all that differential is today. But again, I recommend that you start getting some other reference material.
Before when I asked you if I could do an apology, I didn't know if you thought I was going to be real, but I really need to because I just got my OLEDs that I ordered, and I'm going to go to Mauser to get the multiplexer if the OLED can work with a framework, and then I'll go learn the C language and program it all out once I got it done. But I'm sorry that I didn't know it was going to be more entry level, and I didn't realize how much you knew. I mean, I didn't mean it like that. I didn't mean it like that. Anyway, I don't even know what to say. I'm sorry. Anyway, I'm hella thrilled because these OLEDs are hot. Okay, and so they look, and I could get a multiplexer now as soon as I get paid. And all I want to do is see one work today, please, and then I'll drop the code and learn the C and go. But I can't get the multiplexer until. But are you guys going to Mauser? Is that where everybody's going, or for parts? Or?
Yeah, Mauser is a good one.
Mauser?
Yeah, Mauser or Mauser, however you wish to pronounce that, is a good one. DigiKey is another great component, a component store. Let's see. There's parallax as far as sensors and boards and shields and all that kind of stuff. Then there are stores like Pololu and Parallax. So electronics wise, you've got like two different areas. You've got embedded parts and sensors and boards. That's where the Pololu and Parallax stores come into play. And then on top of that, separately, you've got stores like DigiKey, Mauser, those types of places that cater to specific components like resistors, hookup wire, breadboards, that kind of thing. And then, of course, then there's some overlap between those two stores. But you want to, depending on what your particular need is at the time for a purchase, you want to know if you can get an actual embedded board from that vendor versus just buying, say, a package of resistors or an assortment of resistors or capacitors, something like that. So you want to be aware of that mix as well.
So I've heard of Mauser on the one side, Parallax is the other side.
So Parallax is one. There's Pololu. Off the top of my head, I can't think of all these different vendors. But we can chat on that in the Discord server as well. Okay.
The what?
I say we can chat about that kind of information within the Discord server. I don't mean to cut you off, but
no
is there going to be anybody else on the call who has any feedback or questions or comments from what we covered today?
Yeah.
Yeah. Go ahead, Brian.
So you've mentioned that the Arduino language is based on C and C++.
Correct.
I guess specifically for the Uno, which one is it more of, I suppose?
Let's see. I suppose, well,
like how much can I rely on C syntax and that kind of thing?
Right. So I recommend really to answer that right off the top of my head. I can't answer that very intelligently. I'm thinking about it's like about a 50-50 mix. A lot of boards and languages, a lot of boards and libraries, etc., that come with various sensors and whatnot, they provide usually an interface of either C or C++. As far as the Arduino language itself, I think it is really, now that I think about it, primarily C++. And the way that you're going to be able to tell right off the top, whether we're talking about C or C++, has to do with a little dot or a period that is specified in the function or method name. And so if you see a dot, that is C++ syntax. If you just see a flat out like function call with no dots in, that means that you're talking about C. And in the Arduino language documentation, I do think that it is primarily C++ syntax. But again, I think it is kind of like a mixed board, literally a mixed pie there. And again, if you go over to the languages material, you're going to see what it is I'm talking about, some specific examples. And by the way, that language document is available in a PDF rather than having to go through and look at the various sections that Arduino.cc provides for for the way that they've got their syntax. They're either their C or their C++ syntax defined for Arduino support. So it's real handy to get yourself a PDF, a printable copy is what I'm getting at. Put that in punch holes in it, put that in a 3-ring binder and have by your workbench whenever you're working, because in that way you can look at categories easier. You can more or less discern the way that the function or method is being defined and the parameters that go with that function or method. Okay.
I see. One other thing. So how ESD sensitive in general are these Arduino things?
Yeah, so that's a good question. You always want to, yeah, I mean they're not super. I wouldn't say that they are super sensitive for ESD. At least I personally haven't experienced that. ESD has to do with electrical destruction.
Electrostatic discharge.
It has to do with static discharge that you at your workbench or wherever it is that you're working, wherever you're handling a sensitive piece of electronics. That's always especially true with any kind of boards that you're handling, not necessarily individual resistors or LEDs. ESD does not really not come into play with those, but with any kind of board, whether we're talking about something that's inexpensive, like an Arduino board or product, you always want to practice ESD techniques. So what you want to do is on your workbench, you want to have ESD protector coating that's on your workbench. You always want to you always want to have a like you can buy like cuffs for your shoes that are ESD protection compliant. You really should have a good a setup like that for your board. But in most cases they are not super ESD sensitive.
Call it an ESD mat for your
for your workbench.
Do you see how fast I turned from being a total?
So Brian, does that answer your question?
Yeah, so I guess I do need to pick up like an ESD mat and like some cuffs or whatever the case is, like a
that's right.
bracelet
Yeah,
or
right.
something.
Like a bracelet. Right. And then what I personally do whenever I start for a work session on my workbench is that I make sure, because I've got carpet in my workshop, is that I always make sure that I take my shoes off. I mean, sure, that's not totally going to help matters, but I always make sure that I try and desensitize myself as much as possible before picking up that component board and doing something with it. In addition to having the cuffs on, utilizing the ESD protector surface on your workbench, you'll always, like you say, you brought out a very good point, Brian, because you always want to be conscious of that electric discharge.
Isn't socks on carpet going to be more static?
It could be. You could even, just to be on the safe side, go barefoot whenever you're actually doing component hooks.
I might put a lock on my shoes.
So anyway, that's an idea. But you're right, Brian. That's something to always be cognizant of.
Okay, that's really, really good to know.
So it's better to go to Barnes and Noble and pick up a book, because if I know if I go online.
So here's what I recommend for getting some of these reference materials. I personally, I'm old school because of my education background and whatnot, where I physically like physical books, printed physical books. The trouble is that nowadays they are so darn expensive to purchase, whether we're talking about something used or we're talking about a new book. What's great about the references that I'm providing that I suggest to you is that they're older. They're, being that C and C++ especially have been around for so many decades. There you can get good quality textbooks electronically. You can get ebooks, downloadable ebooks completely for free. Okay, what you can do over in your Google browser, whenever you do a Google search, you can do searches for C++ textbook free PDF. And you'll be able, that's just an example search string. And you can get these materials completely for free. If you don't mind reading electronically, you can do, like individual chapter printouts from using your printer for a lot of these ebook materials. You can get by completely, you can get by either very, very cheaply or completely free if you go with getting free ebook materials. That's the way that I primarily get reference material nowadays, because I'm not a person who overly likes having to sit and read through a bunch of web page material. I like having like a textbook style. That's the way that I've always learned and studied. And so if I can
I don't get distracted. I'll get distracted if I get online and I try and look up C, I'll get one code and I'll start programming.
Oh yeah,
as
right.
to
Yeah, no, you want to get a good quality textbook that covers those specific languages.
Okay, I hope my OLED works today, because then I'll be down the right track, and that's mostly what I'm concerned about. But you guys have set me on this. And can you write everything in C++ from the hardware level, and it'll work? Or do you have? I mean, why start with C? That's the same question I believe somebody else asked. But
right. So, well, okay. So C, first of all, C is much easier to learn. Okay, because you're not in the realm of object-oriented programming. Object-oriented programming is a completely different what's called paradigm or way of programming. Procedural languages like C relatively are easier to learn. The syntax, the concepts are easier to grasp, especially for somebody who is newer at computer programming in general. Procedural languages are easier and faster to pick up. That's one reason why C is great. Okay, versus C++, you have to learn about objects. You have to learn about polymorphism. You've got a whole slew of confusing terms, methodologies, and concepts to not only have to pick up the syntax and the way that you program with an object-oriented language, but you also have to learn all of these crazy sounding terms and the way to apply them. Object-oriented programming is a step up in the learning curve from procedural programming. Is the basic thing. So that's why if you can get by initially, depending on your skill level, where it is that you're coming from, in utilizing and working with Arduinos, is that you want to start from a basic point where you don't have to have quite as big of a learning curve. And so if you're sticking just with C initially as much as possible, and the Arduino IDE, the Arduino language itself fully supports C. So that's why I recommend that a lot of you start there. Okay. Because OOP and C++ is a whole different animal. The complexity just skyrockets in utilizing C++. Okay.
Can you be honest with me? If I write it in C and I learn C, is the C language going to go away?
No. The C language.
Arduino?
I mean, at least as far as I know, the C language is here to stay, and especially for embedded systems. It has been in the past, and as far as I know, will continue in future, including with Arduinos. Both C and C++ will be supported. And that's because of the power, the programming power that is provided both with C and C++ in comparison to all of these other languages, both new generation, experimental languages, what have you. They don't compare, especially for embedded systems, with either C or C++. That's why I say that they are here to stay. And if you go online and you read any kind of articles or predictions for the future with embedded systems, you'll see what it is I'm talking about and the power that you have with those languages.
I'm sorry, what's an embedded system?
So an embedded system is like an Arduino board. In that you're adding things to the board for either inputs or outputs, for either inputs as far as getting stuff into the board or outputs as far as controlling something. Okay, that's what an embedded system is. And an embedded system takes a different programming methodology than, say, programming on a typical PC or on a server. That that is a different methodology for programming than what we are learning here with embedded systems. And part of that difference comes in the realization of having a host or a development system, a development PC to actually write your code, compile it, and download it into your board, versus the PC style where you've got an IDE and everything just kind of happens seamlessly and you don't even think about it, either memory or the way that the code is compiled and used by the computer. It's entirely different. The pieces of the pie are very, very different conceptually.
So are you saying so would something like VS Code be smart?
I'm sorry, what was your question or your statement?
Would it be smart to go with VS Code, or can you use VS Code to upload to your?
Well, you can't. That's where that Platform IO IDE comes into play. Let's see. So I don't know outside of VS Code use with Platform IO. I'm not sure if you can or not with Arduino boards. You can do a search online about that.
Well,
but what I would do initially, depending on your skill level here, is I would start with your learning, your explorations of just sticking with the Arduino IDE for the development system itself.
That's what I think too, because I saw VS Code in my directories and I was like, well, I don't know why it's in there, but
okay. So what else does anybody else have for either statements or questions?
So what exactly is loaded in the EEPROM? Is that?
Oh, so the EEPROM is like for data that you want to, like configuration data. There's a lot of embedded systems, either hobby or especially commercial wise, that utilize persistent configuration type data, where the data, say like for instance, to do with serial numbers or some sort of product codes or something, you can just kind of visualize some stuff that needs to be persistent between that is available in a particular memory spot called the EEPROM in this case, that is fetchable, that is accessible by the CPU, is accessible by the CPU to fetch on boot up or at different stages of execution of a program.
Like I know what EEPROM is, but like, is our code going to flash RAM or is it?
Flash. So in general, code, the Arduino code goes to flash because that's
so. Is basically the Arduino is booting up from the EEPROM then?
No, it does not boot up from the EEPROM. It has a special resident boot monitor and boot environment. The way that any embedded system boots is from a resident place on the board and on the board to do with the way that everything is set up. So it boots from that, and then it goes in and it accesses flash. This is typical for the way that they boot up, and then they go in and they access flash.
Hear this. Please, I'm sorry, I didn't hear this.
And so it does that, and then it goes over and it starts accessing as needed EEPROM, all that kind of stuff. So, but no, it does not directly boot from EEPROM in a typical fashion.
So when we're picking a different board and there's different amounts of EEPROM, when can we access that EEPROM from our program? Like,
well, let's see. So what you do whenever you're developing your program, remember one of those videos that we saw today, they talked about 3 different sections of Arduino IDE programs. They talked about initialization, they talked about setup, and they talked about loop.
Right.
Loop is the AKA or the similarity of main within either C or C++ environment.
Right.
So that's where that loop versus main comes into play. But anyway, so you got initialization, you got setup, and you got loop. So in initialization, you initialize your various areas of memory, and you set up your variable types, your accesses in the different areas of your memory spaces that you want to utilize, including with persistent EEPROM memory. And then in setup, then you initialize those memory spaces, initialize access into them, and then within your loop, depending on if you're using a real-time operating system or you're just utilizing raw Arduino code, then in the various tasks or flow of your main program within your loop is when you go off then you access, depending on the way that your system is configured, the functions and the requirements of your system. Then they go off. Then that program goes off and it accesses EEPROM as needed. So in other words, you have to initialize the access into those various memories, and then once that all of that setup and initialization is done within your structure of your program, then as needed, then the program, depending on the logic, the way that you put together your program, then the program is free to go in and access all of these different areas of memory as necessary. Because in the case of EEPROM, then that persistent data is just there. It's there for the program to utilize at any time that it's needed. Okay.
Well, flash RAM kind of works the same thing, the same way that you like. I assume the IDE flashes your program to the Arduino, right? So when you unplug it from your computer, you can run it on a battery, and it's still in flash RAM.
Correct. Right. Well,
and when it's running, if it has variables, that would be in the other SD RAM, right? Is that what we?
That's what I want to know about.
And then the EEPROM, is that accessible through libraries or what?
Yeah, a lot of times EEPROM is accessible by libraries. By the way, EEPROM is a general component part that you can buy separate IC chips to supplement the various types of memory, including EEPROM. The same goes for static RAM or dynamic RAM. Okay, you can buy specialized chips from a lot of these component manufacturers like Mouser, like DigiKey, etc., that are compatible electronically with boards like Arduino to expand your memory footprint that's available to you. And then in those cases, for sure, you can utilize libraries that are part of the Arduino community that are specific to those IC parts for like memory and stuff. But a lot of times you just want to make things more simplistic, you just more want to stay with raw code, either that you're utilizing in C or C++ yourself, or that you're utilizing the Arduino language itself to get in and do all those accesses, to do all those reads and writes to memory locations, and not necessarily worry about libraries. Whenever you start interfacing actual hardware components to your Arduino, then you're going to either want to write your own library. Again, we'll be getting into libraries later on here. Either utilizing libraries that are already pre-written or writing your own. But for sure, once you start interfacing electronics in with the Arduino, you're going to need a software layer that does all that communication. And that software layer is provided to us by libraries. Okay. I hope I haven't overcomplicated your question with my answer.
Hey, Don, a quick question. Is there something we can work on now?
Yeah,
So
so
the next time we meet?
the work on now is in that PDF that I uploaded into the chat, which is like it's two exercises, okay, that are provided in that PDF, one on top of the other, that utilize a breadboard with your Arduino board of choice, hopefully the Arduino Uno. So you have your breadboard, and then you have some resistors, and you have some regular standard LEDs of different colors. And so those exercises in there's two exercises that are in that PDF. What they do is they even provide you with a full set of code that's in there, that can go into your Arduino IDE, actually program it in, compile it, upload it, and actually see it work on your system that you just are working with. So that's the next step that I recommend as far as a next step exercise. Beyond what we covered at the first part of the very first YouTube video that Lloyd played for us today, in the idea about getting the IDE set up on your system, doing some basic proof of concept, hello world kind of environment check and setup. So that's step number one for what you want to do between now and next event or next meeting, is get your IDE set up, get functionality, start learning the IDE environment that's provided to us, start learning how to utilize the serial monitor, start utilizing how to use Tinkercad in addition or in isolation with the Arduino IDE. Again, I provided all these all those links and so forth in the chat. That's what I recommend for next step exercises. Get the IDE set up, and then go ahead and do just some real basic electronic parts experimentations. In fact, if you care to, Marcus, if you care to go a step further, there's lots and lots of online instructable projects or projects that are out on arduino.cc, for example, the website arduino.cc, that provide all sorts of example programs and experimental projects, like mini projects, to go ahead and get you more familiar with the IDE and programming and electronic interfacing.
Okay. And I know based on our last meeting, I did end up picking up this one. I don't know if you can see it.
See, I can't see it at all.
Oh, it's the Super Starter Kit.
Okay, cool.
Project by Elegoo. I don't know if that's okay.
Great.
Yeah, so it comes with a bunch of stuff, so I thought it was kind of cool. All right.
Okay, cool.
Did you say earlier there's an Arduino board that has a dedicated maybe micro SD slot on it?
Oh, yes. Yeah, there's lots of even in Arduino embedded boards, there are several of the higher end boards. I think that by default, natively on the board, that they include SD slots. But a very popular, if you have an Arduino Uno or a Mega, they don't come with a built-in native SD card slot. You'll have to get a dedicated Shield board for that, and those are very easy to get. But with a Shield, you also need to utilize a software library to communicate with that Shield board itself in with your main board. And again, there's lots of choices out there for that. Okay.
What's inside of a microcontroller?
What was that?
What's inside of a microcontroller? I mean, why? Like, I just want to know molecules, or does anybody know what's truly inside of this Arduino? I guess we'll never. The microchip, what's in there? How do they make it so small?
Well, that's where a lot of this fabrication experience over the years really comes into play as far as miniaturization of electronics. But basically, yeah, it's at the electron and proton level. If you do any formal education as far as basics for electronics, you'll learn a lot about the electron and proton part of electronics. But basically, the skill has been found and built in industry over the years to take all of that and actually get it into it to develop these systems in a miniature fashion to actually fabricate the electronics of the way that the architecture, the way that those boards are actually built to actually manifest and actually make it a reality to have that board in silicon fabricated for the electronics.
I think you were saying something about going on the 23rd or something to a robotics place, because it would seem like if you had a robot building this, it would be a lot sharper. I'm just thinking, right? Maybe.
Well, what it is that I mentioned about a robotics event had to do with in May for the SRS. We are having a contest day. It's going to be on May 31st in the Seattle area. Okay. And if you go over, I gave the URLs in the chat. If you go over to robothon.org, you'll see all the details for the contest and the itinerary, the agenda for the day. Yeah, one way that you can utilize your Arduino skills is with building a physical robot. Either simulate it or build a physical robot. And within the Seattle Robotics Society that I'm a member of and part of the committee for, is that we regularly have contest days to bring our built robots to compete with each other.
Well, it's hard for me to get to Seattle, and I'm not even prepared to build a robot.
Okay, well, that's fine. I mean, I was just mentioning that for people because I know that there are some more sophisticated builders that are part of this community. And so I was just throwing that out there as a potential outlet for utilizing the skills. Okay.
Also, those servo motors don't look like they're going to power much. The DC motor that I took apart of a fan seemed a little bit better, but right? Or they got something even better than that, a AC DC motor, or no, you wouldn't want that for a robot, but I don't know. But now we're talking about robots. Like I don't know.
Okay, well, I don't mean to cut everybody off, but I'm going to have to be signing off here. So it's been great seeing everybody today. John or Doug, did you have anything else that you wanted to comment on or share today? Nope. Okay. So like I say, I got to be taken off. So it's been great seeing everybody, and everybody take care. Okay.
Thank you.
Stop the recording.
That was cool. I